All right, looking at question number 5 of the 2019 AP Calculus AB exam. This was not on the BC. This is looks to be an area volume question. I have not read the question yet, so I'm solving this for the very first time. Hopefully I don't embarrass myself. Let's see. So we have a region. This looks like straight up area volume. They haven't asked one of these in a couple of years. I did not predict this either. R is the region, so G is the function -2 plus 3 pi over 2, 3 cosine of pi over 2x. And then we have a function h, which is 6 minus 2 x minus 1 squared. The y-axis line x equals 2. Okay, find the area of R. This is going to be a pretty straightforward setup. It's going to be 0 to 2 of the top function minus the bottom function, and we have to decide which one is going to be the top. Yeah, the top is h, so 6 minus 2 times x minus 1 squared minus the bottom, which is -2, plus 3 cosine pi over 2x. I forgot the x. Dx, watch your parentheses. You probably got a couple of points for that setup. Probably 1 point for the setup. You'll get 1 point for the antiderivative. I'm going to clean this up before I actually integrate it, though. Squared, that will be plus 2 minus 3 cosine pi over 2x, which will be 8. So we're going to do the antiderivative from 0 to 2 of 8 minus 2x minus 1 squared minus 3 cosine pi over 2x. And we have a couple of u subs in here, but they're fairly straightforward u subs. This antiderivative is going to be 8x minus. This next piece is technically a u substitution where you would let u equal x minus 1, but if the inside derivative, if your du is 1, you can just kind of glaze over that and think of like a power rule. So that's going to be -2. X minus 1 will add 1 to the old exponent divided by the new, minus 3. Cosine is the derivative of sine. And again, this one's technically u sub, but this will end up u subbing to sine pi over 2x divided by pi over 2. And then we'll evaluate that from 0 to 2. I think I'm going to grab the 3 over pi over 2 and turn that into a 6 over pi. And we'll evaluate. So that's going to equal 8 times 2, which I think is 16, minus 2 times 1 cubed is 1, so 2/3, minus sine of pi is 0, so that's all going to go away, minus, plug in 0, 8 times 0 I think is 0. That will be minus 2 times -1 cubed over 3 minus 3 times, oh, again, sine of 0 is 0. That's kind of nice. Usually I don't clean up. This one's kind of nice. Should I clean this up? That's just 16. -2/3 minus a, oh, no, it's 16 minus 4/3 is 48, 44/3. Did I do that right? That's dangerous. Shouldn't do all this stuff in here because that's the triple negatives. Is that right? -2/3, you got a bunch of zeros, so that'll be plus. Yeah, that's right. Okay, we're good. So there's question A. Shrink that up, give me some more room. Question B, area R is the base of a solid for each solid at each x, for the solid at each x perpendicular to the x-axis as the area of that. Find the volume of the solid. Now what you need to remember when you are finding volume, they actually gave you a huge gift here. When you're finding volume, it is found by doing the antiderivative from A to B of the area of the cross section, whatever shape the cross section is, and then you have to choose the variable, dx or dy, whatever. In this case, it would be dx because its dx cross sections are perpendicular to the x-axis. They gave you the area of the cross section, which was a huge gift because usually you have to figure that part out yourself, whether it's a disc, a washer, if you want to go shells, squares, things like that. You have to figure out the area formula on your own. This is just going to be the antiderivative from 0 to 2 of 1 over x plus 3 because they gave you that area cross section. dx, that's going to be the natural log of x plus 3 from 0 to 2, which it gives you the natural log of 5 minus the natural log of 3. If you really want to show off, you could write that as natural log of 5/3, but there is absolutely no reason to do that. There we are. Write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated around the horizontal line, y equals 6. That is going to create a washer. We're rotating around a horizontal line. That makes it a dx problem. The area of a washer is pi big R squared minus little r squared. And if you were to draw this, your big radius, you always measure from the axis of rotation to the boundaries. The big radius is from the axis of rotation, y equals 6, down to the lower boundary of the cosine function, which they have labeled g of x. My little radius is going to go from the axis of rotation to the near boundary, which is the parabola 6 minus 2 stuff squared, which they called h of x. Because they don't ask us to evaluate it, I'm just going to leave it in terms of g and h. If I had to actually do the antiderivative, I would use the true functions. This is going to be the antiderivative from 0 to 2 of big R, watch your parentheses, 6 minus g of x squared minus little r, 6 minus h of x squared dx, and you are done. You don't have to actually evaluate it. So, good to see them coming back to traditional area volume questions. Hopefully that was a good one for you.